Good morning, grade 8 students. Today our lesson will be about atoms. What is an atom? What is an atom? So to define atoms, atoms actually are the building blocks of matter. What do we mean by building blocks? So imagine a wall. The wall is made up of what? It is made up of bricks, right? So bricks are the building blocks of the wall. Why? Because they are all identical bricks, and all these identical bricks form the wall. Similarly, the atoms form everything around us, form the matter, but it is the smallest particle. So we can think of most forms of matter as being made up of many small particles. These small particles are called atoms. Now, to proceed with our lesson, we need to know what does an atomic model means. So let's start with a general model. For example, if we have a car, this car is actually a real car and it's 2.5 meters long. If I want a model for this car, I make this a small model. It is similar, but it's much smaller than the real car. That's why we call it a model car, and it's 25 centimeter long, only to represent what is a car. Similarly, in science. So, for example, scientists use models to understand the real world and how it works. Like the globe of the world, how can we represent it as a model? With this globe. This is a model for our Earth. So a scientific model is a simplified representation of difficult concepts or phenomena. So if I want to represent what is an atom, I need an atomic model. This is the atomic model. We actually have these particles or subatomic particles that represents the atom. The atom is actually made up of a nucleus, this is the nucleus inside, and an electron cloud around it. And in the nucleus we have subatomic particles called protons and neutrons. And in the electron cloud we have electrons. So actually there are three subatomic particles. Subatomic means that they are under the atom, they are smaller than the atom, which are neutrons, protons, and electrons. Now let's try and imagine how small is the atom. Now let's first of all say that it is really small. So this is the cell that we already know that it's microscopic. It has organelles in it, stuff that are smaller than the cell. And in the organelles we have big molecules, macromolecules. And these molecules have smaller molecules, and these molecules have atoms. This is how small is the atom. Now let's try to imagine it by comparing it to something we know, to the size of something we know. Let's imagine that the atom, let's imagine this grapefruit. This grapefruit contains atoms, of course. Let's try and imagine that all these atoms are nitrogen atoms, which is not true, but let's try and imagine it. So, all of these atoms are nitrogen atoms. We want to blow up each atom into the size of a blueberry. Do you know the blueberry? Each atom will be blown up into the size. if we blow them up, all of them, into the size of a blueberry, what is the size of the grapefruit will be? So you can say that the atom is really, really, really small. And if we blow up each atom in the grapefruit into the size of a blueberry, it will become the size of the Earth. That's how much atoms we have in a grapefruit, and that's how much small the atom is. Now, let's try and imagine how small is the nucleus in the atom. So actually, this photo over here is actually wrong. This is not true. The size of the nucleus is barely visible. We cannot see it. We can only draw it like this, but actually this is wrong. This is not to scale. So how small is the nucleus relative to the atom? Let's see. Now, this is the nucleus. Let's imagine it is the size of a blueberry. So this is the blueberry we are talking about, and imagining that this is the atom, right? So if we want to look at the nucleus inside the size of the blueberry, it will barely be visible. We will not see the nucleus. So here we tried and blow up this blueberry into the size of a house. And if we look inside it and search for the nucleus, we won't find it. It will barely be visible also. But if we blow up the blueberry into the size of a football stadium, we will barely see the nucleus now. And it will be the size of a marble. That's how small the nucleus is. So to conclude, if we blow up the blueberry into the size of a football stadium and search for the nucleus, we will find it in the middle, but it will be the size of a marble. So, to sum up our lesson for today, we can say that the atoms are really, really, really small, and they are made up of nucleus, which is much smaller than the atom, and the electron cloud around it. And it is made up of subatomic particles. In the nucleus, we have protons and neutrons. And in the electron cloud, we have electrons. Now, we should also know that these subatomic particles have charges. What do we mean by charges? They even have a positive charge or a negative charge or a neutral charge. Protons, this word starts with a P, so it's actually positive charge. And each proton has a +1 charge. Neutrons have a neutral charge. They are neutral. What do we mean by neutral? Neutral means they have no charge, not positive nor negative. So it's a 0 charge. However, electrons, they hold a negative charge, which is -1. But all this atom actually has no charge. It's a neutral. So if it has positive and negative inside of it, but all of it is a neutral, we can say that the number of protons are equal to the number of electrons and they balance each other, so the atom will be neutral. We will focus on this point in the next video.